These 10 AWS questions separate beginners from 150K solutions architects, and if you can't answer them confidently, you're not ready for the real exam. Welcome back to Tech Cloud Solutions. I'm your instructor, and in part 2 of our AWS SAA-C03 series, we're diving into the questions that actually matter for your career advancement. Question 11. A public trading company hosts its main website's DNS records in Amazon Route 53, where the domain is pointing to an application load balancer. You received a task to direct the user to backup error page if the main website was down. What is the simplest solution to handle this requirement with the minimum changes? A. Use Amazon CloudFront distribution with application load balancer as origin and point route 53 alias record to this distribution. B. Configure Route 53 record to use a latency-based routing policy. Host the error page in Amazon S3 bucket and direct the request to the most responsive endpoints. C. Configure Route 53 active-passive failover. If the application load balancer endpoint is unhealthy, redirect the traffic to the error page, which is hosted in Amazon S3 bucket. D. Configure Route 53 active-active policy with application load balancer and an Amazon EC2 instance hosting an error page as endpoints. If the application load balancer endpoint is unhealthy, redirect the traffic to EC2 instance. The correct answer is C. Configure Route 53 active-passive failover. If the application load balancer endpoint is unhealthy, redirect the traffic to the error page, which is hosted in Amazon S3 bucket. You can use Route 53 health checking to configure active-active and active-passive failover configurations. You configure active-active failover using any routing policy or combination of routing policies other than failover. And you configure active-passive failover using the failover routing policy. Now let's deep dive. Active-active failover. Use this failover configuration when you want all of your resources to be available the majority of the time. When a resource becomes unavailable, Route 53 can detect that it's unhealthy and stop including it when responding to queries. In active-active failover, all the records that have the same name, the same type, such as A or AAA, and the same routing policy, such as weighted or latency, are active unless Route 53 considers them unhealthy. Route 53 can respond to a DNS query using any healthy record. Active-passive failover. Use an active-passive failover configuration when you want a primary resource or group of resources to be available the majority of the time, and you want a secondary resource or group of resources to be on standby in case all the primary resources become unavailable. When responding to queries, Route 53 includes only the healthy primary resources. If all the primary resources are unhealthy, Route 53 begins to include only the healthy secondary resources in response to DNS queries. Question 12. As solution architect, you want to minimize the CPU utilization of EC2 instance resulted from serving a high amount of requests to access static content in S3 bucket. How should you enhance the current architecture to overcome this problem? A. Use Amazon API Gateway with Lambda to retrieve the static contents from S3 buckets. B. Use Amazon CloudFront with S3 bucket as the origin. C. Use a combination from Amazon CloudFront and Amazon API Gateway in addition to Lambda D. Add more EC2 instances and use ELB to distribute the workload. The correct answer is B. Use Amazon CloudFront with S3 bucket as the origin. Use CloudFront to serve a static website hosted on Amazon S3. Let's deep dive. Amazon CloudFront is a fast content delivery network (CDN) service that securely delivers data, videos, applications, and APIs to customers globally with low latency, high transfer speeds, all within a developer-friendly environment. CloudFront is integrated with AWS, both physical locations that are directly connected to the AWS global infrastructure, as well as other AWS services. CloudFront works seamlessly with services including AWS Shield for DDoS mitigation, Amazon S3, Elastic Load Balancing, or Amazon EC2 as origins for your applications, and Lambda at Edge to run custom code closer to customers' users and to customize the user experience. Lastly, if you use AWS origins, such as Amazon S3, Amazon EC2, or Elastic Load Balancing, you don't pay for any data transferred between these services and CloudFront. Question 13. A solutions architect is redesigning the current multi-tier application to solve scaling and performance issues. The application is running in Amazon VPC, which consists of one public subnet and one private subnet. The private subnet hosts multiple EC2 instances, and there is ELB Classic Load Balancer as the front end of the public subnet, and reverse proxy to route the traffic between EC2 instances using that content-based routing. What the steps should you take to enhance this architecture? Select 2. A. Replace ELB Classic Load Balancer and reverse proxy with ELB Network Load Balancer. B. Replace only ELB Classic Load Balancer with ELB Application Load Balancer. C. Replace EC2 instances with C4.large instances. D. Use auto-scaling group with EC2 instances. E. Replace ELB Classic Load Balancer and reverse proxy with ELB Application Load Balancer. The best steps to enhance this architecture and address scaling and performance issues are: replace ELB Classic Load Balancer and reverse proxy with ELB Application Load Balancer. Use auto-scaling group with EC2 instances. Now let's deep dive ELB Application Load Balancer. Offers advanced features like path-based routing, host header-based routing, and cookie-based routing, eliminating the need for a separate reverse proxy. Provides better performance and scalability compared to classic load balancers, especially for HTTP/HTTPS traffic. Auto-scaling groups automatically adjust the number of EC2 instances based on demand, ensuring optimal resource utilization and handling traffic spikes effectively. Helps maintain application availability and performance during fluctuating workloads. Why other options might not be the best fit? Replace ELB Classic Load Balancer and reverse proxy with ELB Network Load Balancer. Network load balancers are primarily designed for Layer 4, TCP, UDP traffic. While they offer high performance, they might not be suitable for application-level routing and features provided by application load balancers. Replace only ELB Classic Load Balancer with ELB Application Load Balancer. While this would improve the load balancing capabilities, it wouldn't address the need for dynamic scaling. Replace EC2 instances with C4.large instances. Upgrading instance types can improve performance, but it doesn't provide a scalable solution for handling fluctuating traffic. By implementing these changes, the architecture will be more scalable, resilient, and efficient in handling increasing traffic demands. Question 14. A solutions architect is designing multi-tier application. The database tier in the private subnet needs to access the internet for periodically OS updates. He must ensure that the database will not be accessed from the internet. What is the simplest approach to achieve this requirement? A. Add NAT gateway in the private subnet and add route to it from the public subnet. B. Configure the database subnet network ACL to allow outbound traffic and deny the inbound traffic. C. Enable inbound rule in the security group for HTTP port only. D. Add NAT gateway in the public subnet and add route to it from the private subnet. The simplest approach to achieve this requirement is add NAT gateway in the public subnet and add route to it from the private subnet. Let's understand why. NAT gateway in public subnet, this allows the database server in the private subnet to access the internet for tasks like OS updates, security patches, and software downloads. The NAT gateway acts as an intermediary, translating the private IP addresses of the database servers to public IP addresses when they initiate outbound connections. Route from private to public. This ensures that all internet-bound traffic originating from the database servers in the private subnet is routed through the NAT gateway in the public subnet. This prevents direct inbound internet access to the database servers, enhancing security. Key considerations. Security groups. Implement robust security groups on the database servers to further restrict inbound and outbound traffic based on specific ports, protocols, and IP addresses. Network ACLs. Use network access control lists to filter traffic at the subnet level. You can configure NACLs to allow outbound traffic for necessary services like OS updates, while strictly denying all inbound traffic. Regular security audits. Conduct regular security audits and vulnerability assessments to identify and address any potential security risks. By combining these measures, you can effectively allow the database server to access the internet for necessary updates while maintaining strong security and preventing direct internet access to the database. If you're finding this helpful, don't forget to like the video. Hit subscribe and turn on the bell so you never miss the next part, and share it with a friend preparing for AWS. Question 15. A client has unencrypted data in Amazon Redshift cluster and asked you about the best technique to encrypt data at rest. What is your recommendation? A. Move the Redshift cluster from public subnet to private subnet. B. Use the AWS KMS. C. Use SSL TLS. Use Amazon EBS volumes. The correct answer is use the AWS KMS. Exam tip: AWS KMS is best option. Encrypt the data at rest in Amazon Redshift cluster. Now let's deep dive. In Amazon Redshift, you can enable database encryption for your clusters to help protect data at rest. When you enable encryption for a cluster, the data blocks and system metadata are encrypted for the cluster and its snapshots. You can enable encryption when you launch your cluster, or you can modify an unencrypted cluster to use AWS Key Management Service, AWS KMS encryption. To do so, you can use either an AWS managed key or a customer managed key, CMK. When you modify your cluster to enable KMS encryption, Amazon Redshift automatically migrates your data to a new encrypted cluster. Snapshots created from the encrypted cluster are also encrypted. You can also migrate an encrypted cluster to an unencrypted cluster by modifying the cluster and changing the encrypt database option.